Multiple studies agree that in crop production systems, finding a balance between profitability, productivity, and environmental health is so important for agricultural sustainability. In the United States, majority of cropping systems suffer from limited species and management diversity and a large use of agrochemicals, such as nitrogen fertilizers. This adds up to having a huge negative impact on the environment. A number of articles support that nitrogen fertilizers are having a detrimental effect on the ecosystem and economy, as their manufacture relies on non-renewable fossil fuels. An experiment conducted from 2003 to 2011 in Iowa aimed to determine what effect diversifying crop systems with a rotation of small grain and legumes, as well as reducing the amount of fertilizer and herbicide use, would have on the grain yields, mass of harvested product, and overall profit.
The control experiment was a 2-year rotation field of maize and soybean, which used conventional application rates of fertilizers and herbicides. The 2 test experiments were a 3-year rotation of maize, soybean, small grain, and red clover, and the other was a 4-year rotation of maize, soybean, small grain, and lucerne.
Both test experiments were managed with lower synthetic nitrogen fertilizer and herbicide use and periodic application of cattle manure. Significant amounts of nitrogen were added through natural fixation by the red clover and lucerne, which was analyzed by soil testing. Weed control in the 2-year rotation was by conventional herbicide application, whereas weed control in the 3 and 4-year rotations used herbicide applications only in 38 centimeter wide bands.
Results found that the increased cropping diversity in the 3 and 4-year rotations produced increased yields and crop mass. Over the 8-year period, maize crops in the 3 and 4-year rotations recorded 4% greater yield than the maize in the 2-year rotation, and soybean in the 3 and 4-year rotations recorded a 9% greater yield on average. Profit made was equal over the 3 cropping systems, with the 3 and 4-year rotations using significantly lower amounts of nitrogen fertilizer and herbicides. However, both recorded higher labor inputs than the 2-year rotation.
It was found over the 8-year study that the 2-year rotation continuously required larger and larger amounts of fertilizer and herbicide application to maintain the initial soil conditions.
Weed control over the 3 systems found that all recorded effective management, even though the 3 and 4-year rotations reduced herbicide use by 88%. The graph shows that the 2-year rotation recorded less viable weed seeds and lower weed biomass. However, the 3 and 4-year rotations recorded lower weed toxicity potential.
In summary, diverse systems increase crop yield and mass and labor inputs. However, they reduce synthetic nitrogen fertilizer and herbicide use, as well as potential weed toxicity. Overall, cropping system diversity is essential for environmental sustainability, and it improves soil and thus crop quality while maintaining and even improving profit and productivity.